So assume that this is my so if the interferer is a level 50 to 60 dB above the desired signal, so this is the desired signal, and assume that this is going to be the interferer. And the interferer, you see, it is having a lot of power, and it is slightly away from the desired, slightly close, 900.4. So the frequency is very close. So then how can I filter this 900 alone? I have to use a very narrow band pass filter. See here, I have to use a filter which will exactly filter out this frequency alone. And this is completely rejected even though the power level is very high. See here, if the interferer is above the desired signal level, the Q value should be very high. Only when Q is very high, the bandwidth is less. Q is equal to F naught by bandwidth. So when Q value is very high, bandwidth is less. So Q value has to reach millions, 10 power 6. Secondly, a different carrier frequency may be allocated to the user at different times. So see, this 900 is at this particular time. If this 900 is not available, the user may get 900.2, 900.4, 900.6. So every time when the frequency is changing, I cannot change the filter characteristics because filters are fixed devices operating in a particular frequency. They cannot be tuned. If they have to be tuned, then there should be some mechanism to change the frequency automatically. So that becomes a very difficult requirement to implement in wireless communication. Okay, so that is also the first one is Q is very large. Second issue is if Q is very large, bandwidth is very small. That is going to solve my issue. But if the frequency of my desired signal is going to change, then even that filter will become useless because the filter works only at a one particular frequency, 900 megahertz in this example. Okay. So how to overcome this? So the type of filtering is called as channel selection filtering to indicate that it selects the desired signal and rejects the interference in other signals. So I'm going to use a special type of filtering called as channel selection filtering. So which channel is selected, accordingly, my filter will also change its characteristics. So that is going to make my filter also have some amount of intelligence. So receiver filter is also going to have some amount of intelligence by using this channel selection filtering, where if a particular channel is selected, the filter will work for that particular channel. It will reject all the frequencies outside this channel. So my receiver will be free from all the noises. All the stages must have this filtering. See, this channel selection filtering, I cannot use it in one receiver section. I have to use it everywhere because I don't know at what point of time what frequency is changing. So whatever, how many ever receiver units I have to use the channel selection filtering everywhere. So which is going to increase my cost. And channel selection filtering, as we say, it by saying it through words is very simple, but it is extremely difficult to implement because when the frequency is going to change, the component values are going to change according to the circuit behavior is going to change. I'm going to shift the bandwidth. I'm going to shift the response of the filter from one frequency to another frequency. Right. So that is not going to be a very easy task. So channel first one, all the receivers will have this filtering. Second one, channel selection filtering, as we say, it is not that easy to implement because changing the frequency is not that easy when compared to and the channel frequency is getting changed.